So this is a conic section in polar form. We don't know whether it's a hyperbola. We don't know which way it faces. But if we put it in standard form, we can learn a lot more about it. So we need 1 here in the denominator. And then we'll worry about the E and the P and everything else like that. So if we're going to have a 1 in the denominator, then we need to factor out a 9 from the denominator. So this is R equals 1 over 9, 1 minus 4/9 cosine theta. Okay, and so we've got our 1, just like it's supposed to have. We got a minus sign, which is an option in standard form. And it's 4/9 looks to be our E. So the 9, you can take care of it by making it just 1/9 in the numerator. That's equivalent, okay? So E is, that's a terrible looking 4. E is 4/9 for our problem. Okay, and then you could identify P too. There'd be a little bit of algebra, but I think for these problems we don't need to identify P because E tells us the shape of the conic section. If E equals 0, if E is between 0 and 1, so that's our criteria here. E is between 0 and 1, so it's an ellipse. It means it's going to have 2 vertices, right? And then to know more about the ellipse, cosine is the denominator. That means the conic's major axis is horizontal, so the ellipse is longer than it is tall. If the sine in the denominator looked like this. And so Newton goes on to give you instructions on exactly how to find those vertices. It occurs at theta equals 0 and theta equals pi. Right? So we just need to plug in theta equals 0 and theta equals pi into our equation that we have up here. Either one, the top one or the bottom one. So theta is 0 for the first vertice, or vertex I should say, I guess. And if you plug in 0 in for theta, cosine of theta is 1, because cosine is the x-coordinates in the unit circle, and if you're at 0 degrees, you're at 1, 0 for a point. So cosine are the x-coordinates in the unit circle. So cosine of 0 is 1, so you've got 9 minus 4 makes 5, so we got 1/5 for the first vertex. I got the video because I was writing angle first. It's supposed to be radius first, so the angle is 0, and when we plug in 0 here, 4 times cosine of 0 is 4, because cosine of 0 is 1. So 9 minus 4 is 5, so we got 1/5 for r, the radius. And then the next angle is going to be pi. We plug in pi, cosine pi is -1. -1 times -4 is +4, so 1 over 13 is what we have for the other radius. So that's the answer for the vertices in polar coordinates. If they wanted them in Cartesian coordinates, you just need to use those conversion equations to convert from polar to Cartesian.